Hello students, from previous class we started a new chapter, surface areas and volumes. There is nothing new in this chapter. It's very easy. If we know the formulae in our fingertip, we can solve each and every problem. So in the previous class we have learned how to find the surface areas of the combined figures. So in today's class we are going to learn about, or we are going to solve problems on volumes of combined figures, combined shapes, right? So before we get into problems, I wish to recall the formula for all the volumes, right? So volume of cube is A cube, volume of cuboid is length into breadth into h, right circular cylinder is pi r square h, hollow cylinder is pi into r squared minus r square into h, right circular cone is 1 by 3 pi r square h, and sphere 4 by 3 pi r cube, hemisphere is 2 by 3 pi r cube. Hope you are thorough with all these formulae. Now let us get into the problems directly. It doesn't need more than this, right? So directly we will get into the exercise and solve the problems. And one more thing, as far as mensuration chapter is concerned, units is very important. So if you forget to write the units, definitely you will lose marks. So for surface area, the unit is square units. When it comes to volume, it is cubic units. So whatever the units is, you have to put cube, right? If you have centimeter, volume will be centimeter cube. If it is meter, it is meter cube. So don't forget to mention your units. As we did the previous exercise, in this exercise also I am going to brief you the concept and the methods to solve the problem, and you are going to solve it, right? Now let us get into our first question. A solid is in the shape of a cone standing on a hemisphere with both their radii being equal to 1 centimeter and height of the cone is equal to its radius. Find the volume of the solid in terms of pi. And in the entire exercise, they asked you to use the value of pi as 22 by 7. And in this problem, they asked you to express the answer in terms of pi itself, right? So what is given? There is a solid which is in the shape of a cone standing on a hemisphere, right? There is a cone which is standing on a hemisphere with both the radii being 1 centimeter, and the height of the cone is also equal to its radius, right? So radius of the hemisphere. So whenever you have a combined shapes, you write the given part like this so that you will get a better clarity. So we have two shapes here, one is cone, other one is hemisphere. Out of cone, what are all the dimensions? You know, height of the cone is equal to its radius. So height and radius both are 1 centimeter. Hemisphere radius is 1 centimeter. What they asked you to find the volume of the solid. How we can find the volume of the solid here? Volume of the solid is equals to volume of the cone plus volume of the hemisphere. That's all. What is volume of a cone formula? 1 by 3 pi r square h. Volume of hemisphere is 2 by 3 pi r cube. So to substitute in this formula, we should know the radius and height of the cone, which is directly given in the question. Similarly, for volume of hemisphere, we need only the radius, which is also given in the question. So directly if you substitute the values, we can arrive at the answer. You don't want to substitute the value for pi because they asked you to find the answer in terms of pi only. So only substitute the values for radius and height, and hence you will get the answer in cubic units in terms of pi, right? Hope you got it. Let us move on to the next question. See, Rachel, an engineering student, was asked to make a model shaped like a cylinder with two cones attached at its two ends by using thin aluminum sheet. The diameter of the model is 3 cm and its length is 12 cm. If each cone has a height of 2 cm, find the volume of air contained in the model that Rachel made. Assume the outer and inner dimensions of the model to be nearly the same. So what they are trying to express at the last sentence, we don't want to consider as a hollow cylinder. They told the inner and the outer dimensions are almost the same. So assuming in that way, they asked you to solve the problem, right? So what model that Rachel has made, it's like a cylinder with two cones attached at its two ends, right? So there is a cylinder with two cones attached at its two ends, right? And it is given the dia of the model is 3 centimeters. So the diameter is 3 centimeter and the entire length of the model is 12 centimeter. So the length of the entire model is 12 centimeter. If each cone has a height, each cone's height is 2 centimeter, then find the volume of the air contained in the model. So how to find the volume of air contained in the model, which is nothing but volume of this cone plus volume of cylinder plus volume of this cone, right? So volume of air contained in the model is nothing but volume of both the cones plus volume of cylinder. So before that we can mention what are all the dimensions given in the question. For cone, they have given you height 2 centimeter and dia is 3, therefore radius is going to be 3 by 2. For cylinder, it is given the dia is 3, therefore the radius is 3 by 2, but they didn't explicitly give the height of the cylinder. So how to find the height of the cylinder? The entire height of the model minus height of this cone and height of this cone, because this is the height of the cylinder, alright. So from the total height we need to subtract this and this. We know this is 2 centimeter, which is given in the question, height of the cone. So 2 plus 2 is 4. So 12 minus 4 is going to be 8. So height of the cylinder is 8 centimeter. Right? So we got all the things. So we can substitute directly. What is volume of a cone? 1 by 3 pi r square h, but 2 times, right? And volume of a cylinder is pi r square h. I have simplified here by taking... And while substituting the values, be careful where this h denotes the height of the cone and this h denotes the height of the cylinder, where both the heights differs. For this it is 2 centimeter, for this it is 8 centimeter. Alright. So substitute the values carefully and then find the answer. Yes, hope you got it. Let us move on to the next question now. Now we are in the third question. A gulab jamun, yes, Diwali special sweets. A gulab jamun contains a sugar syrup up to about 30% of its volume. Find approximately how much syrup would be found in 45 gulab jamuns, each shaped like a cylinder with two hemispherical ends with length 5 cm and dia 2.8 cm. So what is given? A gulab jamun is not in a sphere shape, it is in a cylindrical shape with two hemispherical ends. It is in a cylindrical shape with two hemispherical ends, right? And its dimensions are all given, and it is being given that each gulab jamun has 30% of its volume sugar syrup. It contains 30% of its volume sugar syrup, right? So they asked you to find how much sugar syrup does 45 gulab jamuns will contain. So what are all the things we have to find out now? First we have to find what is the volume of 1 gulab jamun, then what is the volume of 45 gulab jamuns, then what is the volume of syrup. How to find the volume of syrup? Volume of syrup is 30% of volume of 45 gulab jamuns, right? Because 1 gulab jamun has 30% of its volume, right? Therefore, 45 gulab jamuns will have how much sugar syrup? 30% of 45 gulab jamuns. So, we need to find the volume of 45 gulab jamuns, right? So, what are all the shapes involved here? Hemisphere and cylinder. Hemisphere dia is given, right? Therefore, radius is 1.4 centimeter. And for cylinder, again the radius is going to be 1.4, but its height is not directly given. Instead, they have given you the length of the gulab jamun is 5 centimeter. So how will you find the height of the cylinder? Height of the cylinder will be this height. These two heights we have to subtract from the total height. So this is radius, right? This is also radius. So 1.4 plus 1.4, it is going to be 2.8. If we subtract 2.8 from 5, it is going to be 2.2. So 2.2 is the height of the cylinder. Alright. So we got everything. Therefore, volume of 1 gulab jamun is volume of 2 hemispheres plus volume of cylinder. We know volume of hemisphere is 2 by 3 pi r cube and radius we know, and volume of cylinder is pi r square h. So we can substitute and find the volume of 1 gulab jamun. Therefore, volume of 45 gulab jamuns will be 45 into volume of 1 gulab jamun, right? If we multiply it by 45, it will give you the volume of 45 gulab jamuns. Therefore, actually asked question is what is the volume of sugar syrup? What is the volume of sugar syrup? 30% of volume of 45 gulab jamuns. So after finding the volume of 45 gulab jamuns, we have to multiply it by 30 percentage. 30 percentage means 30 divided by 100. So don't forget to give your units. Its units is going to be centimeter cube. Right? Hope you can do this problem. Hope you understood. Let us move on to fourth question now. A pen stand made of wood is in the shape of a cuboid with 4 conical depressions to hold pens. See, it is a cuboid and conical depressions is being made on a pen stand. The dimensions of the cuboid are 15 by 10 by 3.5 centimeter. Radius of each of the depressions is 0.5 centimeter and depth is 1.4. Find the volume of the wood in the entire stand. So they asked you to find the volume of the wood required to make this stand. So if you visualize the stand itself, we will get an idea. It is not a complete cuboid. It is a cuboid where 4 cones is being digged out, right? Therefore, the volume of the pen stand is going to be, the wood required to make this pen stand is going to be volume of the cuboid. We have to subtract from the volume of the cuboid. We have to subtract 4 times the volume of these cone, because that shape is being removed out from the cuboid, right? So 4 times volume of this cone should be removed out. So volume of the wood in the entire stand is going to be volume of cuboid minus 4 times volume of the 4 cones, right? See, the cuboid measurements is being directly given and cone measurements also directly given in the question. Therefore, volume of wood in the entire stand is going to be volume of cuboid minus 4 times volume of cone. If you substitute in the formula, we can get the answer, right? Now let us move on to the next question now. Now we are in the fifth question. A vessel is in the form of an inverted cone. Its height is 8 centimeter and radius of its top, which is open, is 5 centimeter. So it is inverted cone shape. Height is given, radius is 5 centimeter. It is filled with water up to the brim. When lead shots, each of which is a sphere of radius 0.5 centimeter, are dropped into the vessel, 1/4 of the water flows out. Find the number of lead shots dropped in the vessel. So what is given? There is a cone shaped vessel, right, and the water is filled up to its brim. When the water is up to the brim, when you put some weights into the vessel, what will happen? The water will displace out, right? So in such a way, they are placing some lead shots inside the vessel. When they place lead shots, 1/4 of the water is flowing out of the cone. 1/4 of the water is flowing out of the cone. So they asked you to find how many lead shots is being dropped into the vessel, right? So the lead shots in the shape of a spear, which is also given in the question. So 2 shapes are involved in the question. One is cone, the other one is spear, right? Both the measurements are directly given. Now to find the number of lead shots dropped. Let n be the number of lead shots dropped. Then what do you infer from the question? The volume of water displaced will be equal to volume of lead shots dropped. Yes or no? The equal volume of water only will displace out. Yes. So the volume of water spilled will be equal to volume of dropped lead shots, right? But how many lead shots is being dropped? We don't know. So we have assumed it to be n. N times, each one is of the shape of spear. So volume of spear is 4/3 pi r cube, right? So n times 4/3 pi r cube. This side, not the entire volume of the water, not the entire water dropped out, spilled out. Only 1/4 of the water is spilled out. What is 1/4 of water spilled? Which is 1/4 of the volume of cone, because the vessel is in the shape of a cone, right? So 1/4 of the volume of cone. Here I have mentioned this is R1 and R2 because there is a difference between the radius of the cone and the spear. So to avoid confusion, in hurry when you are solving your problems during your exams and all, on seeing R, H, don't blindly substitute the values, right? So understand it, whose radius are you going to substitute. Have a clear idea and then substitute. That's why I asked you to list out the dimensions of the different shapes by naming it. So that when you have a cone, you can check out the radius under cone. When you have spear, you can check out the radius under spear, so that you can avoid your confusions and last minute wrong substitution of the values, right? So hope you got it. So volume of water spilled will be equal to volume of dropped lead shots. So we have assumed it to be n. So n times 4 by 3 pi r cube. So if you substitute all the values, we can find what is n, because our question is to find the number of lead shots. So number of lead shots is going to be this volume divided by this. Right? You can simplify and get your answers. Don't blindly cancel r, because both the r's are different. So substitute the values and then cancel it. Yes. Hope we can move on to the next question. We are in the sixth one now. A solid iron pole consists of a cylinder of height 220 cm and base dia 24 cm, which is surmounted by another cylinder of height 60 cm and radius 8 cm. Find the mass of the pole given that 1 cm cube of iron has approximately 8 gram mass. This also you have to notice, few questions they have given you the dia and in few questions they have given you the radius directly. So read the question, make a clear idea about what is given and then proceed with your problem. Okay. So what is given, there is two cylinders, one cylinder over the other. They asked you to find the mass and they have clearly given 1 centimeter cube has 8 gram mass. So if we find the volume of the entire pole, we can multiply it by 8 gram, because 1 centimeter cube is 8 grams. So that much centimeter, how much gram of mass it will contain, we can find out, right? So see, there is one cylinder over another, right? I have named it as cylinder 1 and cylinder 2. It is clearly given, the first one length is 220, height is 220 and dia is 24, so radius will become 12. And the second one, radius is given, so it is 8 and its height is 60. Now they asked you to find the mass of the pole, right? So volume of the pole is going to be volume of this cylinder plus volume of this cylinder. Pi r square h, pi r square h. I have differentiated with r1 h1, r2 h2. Then after finding the volume, it is given mass of 1 centimeter cube is 8 gram. Therefore, mass of the pole is going to be 8 into volume of pole, right? So this units will be in gram. Mass is in gram. So units is very, very important. I am repeating again and again. If you miss out, you will lose marks even though the entire problem is correct. Yes. Hope you got it. Let us move on to the seventh question now. Seventh question, a solid consists of a right circular cone of height 120 cm and radius 60 cm standing on a hemisphere of radius 16 cm is placed upright in a right circular cylinder full of water such that it touches the bottom. So a solid consists of a right circular cone. First there is a cone and standing on a hemisphere, that is standing on a hemisphere. So a cone on a hemisphere is the solid. This entire solid is placed upright in the right circular cylinder. This entire solid is being placed inside a cylinder which has full of water, right? And this hemisphere touches the bottom. So find the volume of water left in the cylinder if the radius of the cylinder and the height is. So how much water will be left in the cylinder if we place the solid? This is same as this problem, the lead shots dropped. So how much water spilled out will be equal to the volume of the solid which is being placed inside, right? The volume of the solid which is dropped inside the vessel will be equal to the volume of the water spilled out. In this question they asked you to find the number of lead shots. But the concept is near same here. Here they asked you to find the volume of the water left in the container, right? Volume of the water left in the container after placing the solid inside the cylinder. So how we can solve this problem now? Now this is going to be volume of water left in the cylinder is volume of the cylinder minus volume of the solid. Right, because that much water only will be left. Volume of the cylinder minus volume of the solid. This is the solid, right? A solid is in the shape of a cone surmounted on a hemisphere. This is the entire solid. This entire solid is being placed inside a cylinder. So three shapes are involved in this problem: cone, hemisphere and cylinder. And it is clearly given all the radius are same. So radius is going to be 60 centimeter. but the height of the cone differs from the height of the cylinder, which is also clearly distinguished in the question itself. Height of the cylinder is 180, height of the cone is 120. Now volume of water left in the cylinder will be volume of cylinder minus volume of the solid. But what is the volume of the solid? Volume of cone plus volume of hemisphere. So substitute in the formula, substitute all the values and solve it. Yes, hope you understood. Let us move on to the last question. A spherical glass vessel has a cylindrical neck 8 cm long, 2 cm in dia. The diameter of the spherical part is 8.5 cm. So there is a spherical vessel which has a cylindrical neck. This type of vessels you might have seen in your chemistry labs. It has a spherical bottom and it will have a cylindrical mouth, right? So cylindrical neck. It is not a mouth, it's a neck. And the cylindrical neck's dia and length is given, and the dia of the spherical part is also given. By measuring the amount of water it holds, a child finds its volume to be 345 centimeter cube. So by filling water inside that vessel, a child found the volume to be 345 centimeter cube. Check whether she is correct, taking the above as the inside measurements and use pi as 3.14. So using these measurements, they are asking you to check whether it is correct or wrong. By filling water, a child has found its volume to be 345. By using this measurement mathematically, they are asking you to check. How to check? We know this is a spherical, don't ask is this sphere, I am poor in drawing. So this is a spherical bottom and has a cylindrical neck. So cylinder measurements are given clearly, and dia is 2, so don't get confused. So radius is going to be 2 divided by 2, 1 centimeter, right? And sphere dia is given. So volume of the vessel is going to be volume of sphere plus volume of cylinder. Find the volume and check whether it is equal to 345 centimeter cube. If it is equal to 345 centimeter cube, you can tell yes, it is correct, or else you have to state that no, she is wrong. That's it, right? So hope you got it. The entire exercise is very easy. It doesn't need any logical skills here, logical thinking. Only if you understand the question, try to express the question diagrammatically so that you will get a better clarity after expressing the question. And if you know the formula, that's it. So if you by heart all the formula, you can excel in this chapter. Nothing else. So and you should be good in your manipulating skills. Calculations you have to be good, because it involves a lot of calculations where you have to multiply, add, divide, all those things you have to do. So if you are good in your calculation skills and if you by heart all these formula, you can very well get through this chapter. So with this, let us wind up today's class, and you have to do entire exercise, which means question number 1 to 8 as homework. All the 8 questions as homework, and post it in the group. If you have doubts, you can ask me. Thank you, students.